Hey guys, welcome back to the channel. This is day 2 of Leetcode daily challenge of August. The problem name is kth element in sorted matrix. It is in the medium category of Leetcode. Now let's move on to the problem. Given an n cross n matrix where each of the rows and columns is sorted in ascending order, return the kth smallest element in the matrix. So the rows and columns are sorted in ascending order. So there is a strong possibility that we need to use binary search for this problem. So there is a note given. Note that it is the kth smallest element in the sorted order, not the kth distinct element. So we need the kth smallest element in the sorted order, not the kth distinct element. So you must find a solution with a memory complexity better than O n square. So the one solution which is coming into my mind is we can put we can maintain a priority queue of maxi priority queue of size k and return the topmost element of it and traverse whole of the matrix. That will be order n log k solution. Uh, the time complexity would be order n log k and the space complexity would be log k. So let me think of a better solution. A better solution can use binary search. So let's see the first test case. Just a second. So what I'm seeing is what I am thinking of doing is we can apply a binary search on the numbers. Like we can start from low from zero, that is the zero and high from 15, and then apply binary search on it. The mid will be equal to 8, and then we will count the number of elements greater than less than 8. If it is less than k, then we will move the low pointer to mid plus 1, or else we will move the high pointer to mid. In this way we can get the answer. The time complexity will be much better as we are using the binary search, and we will be also let me write down the code that things will be more clearer then. So first of all we need to take a variable low is equal to, first of all we need to declare the size of the matrix. It is an n cross n matrix. It is given the matrix is n cross n, so I'm saying n equals to matrix dot size. Now I need to take a low variable. Low is equal to matrix 0 0, high is equal to matrix n minus 1, the last element, nth n cross n minus 1 n minus 1, and then we are gonna run binary search on these numbers. Low is less than high, and at last we are gonna return low. So in mid is equal to low plus high minus low divided by 2. Count is equal to 0. Now I'm going to count the numbers which are less than mid. So that would be done by the upper bound function. Upper bound function gives the index of the element which is the first element which is greater greater than the given element. So uh, for each row I need to know how many elements are less than that number. I is less than n, I plus plus, count plus equals upper bound matrix I dot begin matrix I dot end, and I'm calculating the upper bound for the mid. And now I need to subtract the starting index. It's because we are given the indexes rather than the exact number. Matrix I dot again. And now I am gonna check if count is less than k, then low would be equal to mid plus 1, else high would be equal to mid. And now let's run the code and see if it works. It is working now. Let me submit the code. So it is working absolutely fine. So if I'm gonna share one more approach which is like much more intuitive than this. If you wanna see that, you can continue watching this video, or else you can just leave. That approach, this is the most optimized approach for this problem. So let me uh, go to a more intuitive solution. Rather than in this, I would be using a priority heap of a size k, which will store the k max heap. Basically, I'm using max heap, so which will store the k like the k starting elements of the whole matrix. And whenever get a I increase the size and then I will decrease the size. Let me show how will I do that. Like let's first of all, like let me declare a priority queue int. This is a maxi priority queue, so you don't need to do anything else. Priority queue priority queue. So for int for int I equals to 0, I is less than matrix. I'm gonna traverse the whole matrix dot size I plus plus for int j equals to 0, j is less than matrix dot size j plus plus. Just a second. Uh, so just I'm gonna put push this element ij into the heap matrix I j, and if the size of the priority queue becomes greater than k, then I will pop the element is greater than k. I'm just gonna pop pq dot pop. In this way, the size of the priority queue is maintained to be equal to k, and then I'm just gonna return pq dot top. And let me submit this code and see if it works. So it is working absolutely fine. So thank you for watching. Do like and subscribe my channel.